Students, today we will discuss about the atomic structure of those semiconductors. Take a silicon atom. You know very well the last orbit of a silicon atom is filled with only 4 electrons. Then how silicon will become stable? The thing is that you know very well. Consider only the valence electrons. There are I have shown 4 silicon atoms. So each silicon atom has 4 electrons in their valence band. To attain a stable state, and each silicon atoms are sharing their valence electrons. So now see the animation, you can easily understand the sharing of valence band electrons with the other silicon atoms. Now look at the central silicon atom, it has 2, 4, 6, 8. So it attains the stable state. So if any atom wants to become a stable, that last orbit or the valence band must be filled with the required number of electrons. So here the valence band is filled with the 8 electrons. So like that the silicon atom attains the stable state. Similarly, all the silicon atoms share their outer shell electrons with their neighboring atom. Then only the stability will be attained. So you know very well this sharing bond, this bond is known as a covalent bond. A covalent bond is also called a molecular bond because there is a chemical sharing between these two atoms. It is a chemical bond that involves sharing of electron pairs between the atoms. So each silicon atom sharing their valence band electron, and finally it reaches the stability. And suppose this silicon atom it share their valence band electron with the next silicon atom. So here I haven't shown that other silicon atoms so that it reaches the stability. And likewise, this is a covalent bond, the structure of germanium atom. This germanium atom, it has 4 electrons, valence band electrons, and these 4 electrons are shared by the neighboring atoms, and it reaches the stability or attains the stability. You know very well there are two common types of semiconductor. One is an intrinsic semiconductor, the second one is an extrinsic semiconductor. That intrinsic means it is a pure semiconductor, it doesn't contain any impurities. But extrinsic is just opposite to intrinsic semiconductor. That extrinsic semiconductor is formed by adding the impurities in a pure semiconductor. You take an impurity and add it with the intrinsic semiconductor, you will obtain the extrinsic semiconductor. So it doesn't have any impurities, but it has impurities. That is the difference. And these are the major difference between intrinsic and extrinsic semiconductor. Intrinsic means pure, we are not adding any impurities, so doping or additional of impurity doesn't take place in intrinsic semiconductor. But here we are adding small amount of impurities. So why should we add that impurity? Because we need to make the material as electrically conductive. So that's why we are adding the impurity. The electrical conductivity is low because there is no impurity, but here it is high because there is a presence of impurities. And the dependency of electrical conductivity. Electrical conductivity is a temperature alone, but here that electrical conductivity depends on both temperature as well as the doping or impurities. Electronic devices means these intrinsic semiconductors or the pure semiconducting materials are not suitable for making electronic devices. So we are using extrinsic semiconductor for making electronic devices. So in this lecture, I am not going to concentrate about intrinsic semiconductor. We will discuss only about extrinsic semiconductors. So these are the types of extrinsic semiconductors based on the impurities added. One is a p-type semiconductor, second one is an n-type semiconductor. So for getting p-type semiconductor, you need to add trivalent impurities with the intrinsic semiconductor. To get n-type semiconductor, we have to add pentavalent impurities. And those impurities can be classified as, you know, very well, trivalent and pentavalent. Trivalent is known as acceptor impurities. Pentavalent is known as donor impurities. So what are the trivalent impurities? Boron, aluminium and gallium. Pentavalent impurities are arsenic, phosphorus and antimony. It means that the boron, aluminum and gallium has 3 electrons in their valence band, and arsenic, phosphorus and antimony